kids, welcome to Tuesday, and today we're going to be doing proportional relationships. We're going to be graphing them on the graph today and trying to figure out, are they proportional relationships once they're graphed? Here's the short end of it, is that there's two ways that you have to check off to make sure that they are. One, once you've graphed the ordered pairs, if the line passes through the origin, 0, 0 is your origin, and if it does that, and if it is a straight line, then it is a proportional relationship. You would put yes. If one of the criteria is only met, like it passes the origin but it's not a straight line, it's crooked, then it's not proportional. And we're going to get into it right now with some of these examples. So come on over here. We're going to take a look at this time and distance chart, and we're going to graph it. Okay, so the first ordered pair is 0, 0. So 0, 0 would be right in here with my dot. 0, 0. Then it's 1, 6, and I went by 4s here. So 1 up to the 6 is going to be right in here. Then 2, 12. 2, 12 is there. 3, 18 would be right in here somewhere. And then 4, 24. So 4 up to the 24, to this last one. Of course, I apologize that it's not perfect, but yeah, you get the gist. When I put a ruler, which I didn't do, and I go through each dot, connecting them, I am done with the first part, which says graph ordered pairs. Then it's asking you, the question is, let me read exactly from the book. It says, can determine whether the numbers, the ordered pairs, are proportional. Explain your reasoning. Well, it says it has to pass through the origin, and I know it did because the first two numbers are 0, 0. That is the origin, so that's a check off that list. And then the second thing is it has to be a straight line, and guess what? It is. So explain your reasoning would be, yes, it's proportional. Because it goes through the origin. And it's a straight line. Voila. Let's do this example. And I use the exact same graph just because I want to save time. I'm going to erase this line and this one, since we're doing that one now. We're going to take a look at this one. So 0, 0, you're already going, yeah, it already met that criteria. It goes to the origin, right? 0, 0. And then it says 1, 4. 1, 4 is right here. Then 2, 8. 2, 8 is right here. And then 3, 13. So 3 up to 13 would be right in there. So while, whoops, that part is straight, that part goes a little bit crooked. So it's not proportional. You would say not proportional. It goes through the origin, but it is not a straight line. It kind of went a little slanty.
You could tell because if you said it was a straight line, you could tell because 1 times 4 equals 4, 2 times 4 equals 8, 3 times 4 equals 12.
Exactly. So say that again louder so that the iPad can pick up what you just said.
Even if you said it was a straight line, you could tell that it isn't because 1 times 4 equals 4, 2 times 4 equals 8, and 3 times 4 equals 12, not 13.
Exactly. So that's another way of knowing. You're right. That's another way of knowing. Thank you, Edwin. Now here it might just say, which of these are proportional? Line A or line B? Raise your hand if you think it's line A. Raise your hand if you think line B is proportional. You're right, line A is, because A, well, they both pass through the origin, but the only one that's straight line is line A. Okay, and that's how you justify your reasoning. Pretty easy, right? Bye.